Acceleration is considered along y-axis, time is considered along x-axis. So what is the SI unit of acceleration? It is meter per second square. The velocity of a body is changing with respect to time, which is nothing but acceleration. The body is having initial velocity and it is having a uniform acceleration. So this looks like a trapezium. If you calculate the area of trapezium, you will get the displacement. So now how to check the area of trapezium? What is the formula? Hello everyone. Welcome to session 3 of chapter 3, Motion in a Straight Line. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have discussed about the acceleration concept. What is acceleration? The rate of change of velocity is acceleration. So rate of change of velocity. So velocity is given by meter per second divided by times unit is second. So acceleration SI unit is meter per second square. And also we have discussed about uniform acceleration. That is, the acceleration of a particle is equal in equal interval of time is said to be a uniform acceleration. We even discussed about the instantaneous acceleration. That is, the acceleration of a body at particular instant of time. And next we have discussed about position time graph and the various cases of the graph which is varying between the position and time, and also we have studied about the velocity time graph. In today's session, we are going to discuss some more interesting concepts which includes acceleration time graph. Acceleration along y-axis and along x-axis, it is time. Yes, it is nothing but the graph of acceleration versus time. Acceleration is considered along y-axis, time is considered along x-axis. So what is the SI unit of acceleration? It is meter per second square. So the area under acceleration graph represents the change in velocity, because we know acceleration is rate of change of velocity. So the area under acceleration gives us the change in velocity. How does the velocity of a body changes with respect to time? So to calculate the change in velocity, we can plot acceleration time graph and we can calculate the area so that we will get the change in velocity of the body. Let us now see what are the various cases of this acceleration time graph. How we have to plot a graph when the body is said to have a zero acceleration, a uniform acceleration, decreasing acceleration and increasing acceleration, and so on. So first one we have uniform acceleration. If the body is said to have a uniform acceleration, then the graph plotted is a straight line. Here we can say that the acceleration is uniform with respect to time. As the time changes, the acceleration of a body is not varying, so it is constant and hence uniform acceleration. So next we have uniformly increasing acceleration. The graph plotted for a body which is having increasing velocity, that too uniformly, is given by this graph. We can observe here with respect to time, the acceleration is increasing uniformly. It is not constant acceleration, it is not even decreasing, but it is increasing acceleration. So next we have uniformly decreasing acceleration. You can see here the value is getting decreased. The acceleration of a body is getting decreased with respect to time. So any body which is having uniform decreasing acceleration is given by this graph. Next we have variable acceleration, which means the acceleration is changing with respect to time. So varying acceleration is shown as this. That means you can observe here acceleration is varying from point to point with respect to time. So this is about acceleration time graph. So far we have discussed about position time graph, velocity time graph, acceleration time graph and their various cases. Let us now move on to an interesting concept, that is kinematic equations. So what are kinematic variables? So it is nothing but the position, velocity and acceleration and time. They are called as kinematic variables. So by combining all these variables, if the equation is given, then the equation is said to be a kinematic equation. So let us now derive the kinematic equations. What are these kinematic equations? So each variable can be related to every other variable through equations, and they are called as kinematic equations. Here, as I told, kinematic variables are position, velocity, acceleration and time. So each variable can be related to every other variable with the help of equations, and they are called as equations of motion or kinematic equations. So let us see few kinematic equations. Here V is velocity, final velocity, U is initial velocity, A is acceleration and T is time. So these are kinematic variables. So variable is related with another variable with the help of equation, and it is said to be a kinematic equation. So V is equal to U plus AT is one of the kinematic equation. And next we have S is equal to UT plus half AT square, where S is displacement, U is the velocity, T is the time, A is acceleration. Here also the kinematic variables are related with other variables and hence forming a equation called kinematic equation. Next we have V square is equal to U square plus 2AS. Again we can observe the variables are related with other variables and hence it is also a kinematic equation. So now with the help of the VT graph, let us derive this kinematic equation. So now we will come to know what is the significance of this graph. That is, derive the relation V is equal to U plus AT using VT graph, that is velocity time graph. So here you can observe in the graph, velocity is varying along y-axis, time is varying along x-axis. Considering these two parameters is a very basic and important thing. So here they have given with the help of VT graph, we are going to derive the relation V is equal to U plus AT. Now let us consider a body which is moving with uniform acceleration A. Yeah, you can see here the body is moving with a uniform acceleration. Now let us consider U be the initial velocity of a body. In this graph, U is nothing but initial velocity. Here, the velocity of a body is changing with respect to time, which is nothing but acceleration. The body is having initial velocity and it is having a uniform acceleration. And next we have here, the body reaches a final velocity and that is given by V. So V is a final velocity. The body is moving with respect to time. It is having a changing its velocity with respect to time and hence we'll get a acceleration. So here in this graph, U is the initial velocity, V is the final velocity and T is time. We know that the slope of VT graph gives acceleration. Here we have considered the VT graph. Let us calculate slope of this so that we will get the acceleration. So next here acceleration, how can we define acceleration? To get acceleration we need to calculate slope. So let us calculate slope here. So for calculating slope we have taken this triangle ABD. So according to the convention, OA is nothing but U, that is initial velocity, and BC is V, that is final velocity. Now I need only BD, which means this area is equal to V minus this area, that is U. So acceleration is nothing but slope. So slope, how to calculate slope? It is y-intercept divided by x-intercept. Here y-intercept is BD divided by x-intercept is AD. So what is BD? BD is nothing but V minus U and AD is T, because it is the base is same for both this triangle and this rectangle. So even this is a T. So we have V minus U divided by T and that is acceleration. So from this we can write V minus U by T is equal to acceleration. So V is equal to U plus AT. So this is the expression for velocity. With the help of VT graph, we have derived V is equal to U plus AT. Similarly, we can derive one more kinematic equation, that is S is equal to UT plus half AT square. What is S? S is nothing but displacement, U is the initial velocity, A is acceleration and T is time. So for this also we are considering the same graph, that is velocity along y-axis and time along x-axis. Here also we have considered a body which is moving with uniform acceleration and the initial velocity of a body is given by U. V is the final velocity, t is time, and s is displacement is what we have to relate with the other variables. So displacement in time t is nothing but the area under VT graph. Yes, this is the significance of VT graph. Area under VT graph gives displacement and slope of VT graph gives acceleration. Here now we have to calculate displacement. We have to derive the expression for displacement. So to get the displacement, we need to see the area under the VT graph. Area under the VT graph is this thing, so which gives us displacement. So to check displacement, that is S, which is equal to area of triangle ABD plus area of rectangle OADC, which means this is the area of VT graph. If you calculate this area, then you will come to know what is the displacement. Now, how to calculate area? Here in the diagram, it is divided into a triangle and a rectangle. Correct? So, triangle ABD and a rectangle OACD. So, we have the diagram like this. So, to calculate area, we need to take the area of rectangle plus area of triangle. So, that is S is equal to area of triangle ABD plus area of rectangle ADCO or OADC. So, if you take the area of triangle and if you add that area of triangle with the area of rectangle, we will get the total area, which is nothing but displacement. Now, what is the area of triangle formula? It is half into base into height. So, here the base is AD, height is BD. So, it is half into AD into BD. Plus, we have plus here, plus area of rectangle OADC. So, area of rectangle is length into breadth. So, length is OA, breadth is AD. So, it is plus OA into AD. Now, let us substitute what it is given by the variables. So, now let us simplify this. We have S is equal to half T into V minus U plus U into T. This U into T is nothing but UT, half we have here, and next V minus U is nothing but AT. Because we have derived an expression for acceleration, that is V minus U divided by T. From this we can write AT is equal to V minus U. So, in the place of V minus U, you can substitute AT. So, what we will get? S is equal to half into T into AT plus UT, or it can be written as AT into T is nothing but AT square. So, it is S is equal to UT plus half AT square. This is the kinematic equation for displacement. We also can derive this with the help of the another method. There is an alternative method to derive this expression, that is S is equal to UT plus half AT square. In the previous method, we have considered area of triangle plus area of rectangle to check the area, which gives us the displacement. Here also again we have to find the displacement, but we can take the area of trapezium. You can observe here it is of the form trapezium. By calculating the area of trapezium, we can arrive at the same expression. So, now let us see what is this alternative method, how to derive the same expression with the another method. So, here consider a body moving with uniform acceleration with initial velocity u, final velocity v, and t is time, s is the displacement. So, now we know that how to calculate displacement. To check the area and the VT graph, you will get displacement. So, displacement is given by area under VT graph. Now, what is this area under VT graph? It is nothing but this area. So, this looks like a trapezium. If you calculate the area of trapezium, you will get the displacement. So, now how to check the area of trapezium? What is the formula? So, the area of trapezium is given by half into base into sum of two parallel sides. Now, let us consider OABC is our trapezium. Let us apply the same formula to find the area. So, it is given by half into, what is the base? Here base is nothing but OC and sum of the two parallel sides. Two parallel sides are OA plus this one BC. So we'll get half into OA plus BC into OC, that is the area of trapezium. So area under VT graph gives us displacement and hence it is denoted by S. Now S is equal to, what is OC? OC is nothing but T and OA is U plus BC is V. We have half here. Yes, now let us simplify this. How to simplify this? We know V is equal to U plus AT. So let us substitute this for further simplification in the place of V. How do we get this? Because we know acceleration A is equal to V minus U divided by T, or AT is equal to V minus U, or V is equal to U plus AT. So in the place of V, let us substitute U plus AT. So you will get S is equal to half U as it is written, plus in the place of V, we are substituting U plus AT into T. Now let us multiply all these. So we will get S is equal to UT plus half AT square. So there are two methods to find the displacement equation, that is S is equal to UT plus half AT square, by considering the area of triangle and area of rectangle, or by considering the area of trapezium. So next we have to derive the relation V square is equal to V naught square plus 2AS. This can also be asked as V square is equal to U square plus 2AX, where x is the displacement and here s is also the displacement, a is the acceleration, v naught is nothing but the initial velocity, which can also be defined by u. So let us now consider the same graph where the body is having uniform acceleration. It is moving with an initial velocity u in time t, and it is having a final velocity of v. So if v is the final velocity, then vd is given by v minus u. So let us define everything. U is the initial velocity, v is the final velocity, t is time, and s is displacement. Now we are going to derive the relation between the kinematic variables, that is velocity, acceleration and displacement. So now we know s is equal to half into base into sum of parallel sides, that is the area of trapezium. So half into base into sum of two parallel sides. So let us now substitute everything. S is equal to half into base is OC and sum of the parallel sides, that is OA plus BC. So let us now substitute all the variables. So in the place of OC, that is base, it is given by T. So OC is substituted by T into OA is nothing but initial velocity and BC is nothing but the final velocity, that is sum of parallel sides. So we will get S is equal to half into T into V plus U. Now we know that T is equal to V minus U by A. From the acceleration expression, we have A is equal to V minus U divided by T. So we can write T is equal to V minus U divided by A. So in the place of T, we are substituting V minus U divided by A into U plus V as it is. So now let us multiply everything. You will get, here we have V minus U and V plus U, which is nothing but A plus B into A minus B, and the formula of this is A square minus B square. So we can write this as V square minus U square. So in the numerator we have V square minus U square in the next step divided by the acceleration. So the expression is S is equal to half into V square minus U square divided by A. What do we require? V square minus U square is equal to 2AS. So let us now simplify this to get the desired expression. So just multiply the denominator. We have 2 into A, that is 2A, into cross multiply S. So you'll get 2AS, which is equal to 1 into V square minus U square is V square minus U square, which is equal to 2AS. So in today's session, we have learnt acceleration time graph, various cases of acceleration time graph, and what is a kinematic equation, what are kinematic variables, what are the different relation between these kinematic variables, and we have even derived important derivations with the help of VT graph. So in the next session, we will come up with some more interesting concepts. Until then, please take care all of you. Thank you.